All right, for today's stuff, I was asked to go through another example of how to explaining how to work with an axis of rotation that is not the x-axis or y-axis. So this is number 3 off of the practice that I've given you today. We've got y equals square root of x plus 1, y equals x squared plus 1, and our axis of rotation is y equals negative 1. So this is the graph that we've got. The top curve going through there, that is the square root of x plus 1. The bottom curve in this instance is our x squared plus 1. Going through, when we're finding our volumes, this is going to be using our washer method, because if we take our cross section, we are going to have this empty space in between here. Now, working through this, we've got this inside radius. I'll label it r sub I. We've got this outside radius. That's the distance from the axis to the curve, or from the axis to the inner curve there. So I'm going to label that RO. Not too great in there, but it is what it is. Thinking about this, the shape, if we rotate this, there's going to be this empty space in the middle from our axis of rotation. This line going through here, our axis of rotation, that is y equals negative 1. We have the inside radius, we have the outside radius. And so the area of our disk, or excuse me, our area of our washer is going to be pi. We've got pi r squared, so it's going to be the outside radius squared, subtract the inside radius squared. And then from there, we can move on to the volume. Now what I think about is geometrically, there's a distance of 1 from here. Our outside radius, if x is 1, our outside radius, that's going to be at the point 1, 2. So that height there is 2, but it's also adding that extra 1 to go down. The inside radius, well, in this case, it's going to be 1, 2 as well, because that's the intersection point. We also have to add that 1. So if we think about this geometrically, we can use a set example. Right at the start, think about our distances. We have the point 0, 1. Our distance there to our axis of rotation is that 1, that height, plus an additional 1. Well, it's the height subtract the axis of rotation. So the height subtract the axis of rotation. In short, it's y minus negative 1 gets us our radius. In between there, well, any other given point, our height is given by x squared plus 1. That's the distance to the x-axis, but then we need an additional 1. I'm going to go for our outside radius. Still on the screen. We've got pi. Outside radius is square root of x plus 1 plus an additional 1 to get that extra vertical shift in there. Subtract our inner radius. Well, the inner radius is given by x squared plus 1. So we have x squared plus 1 plus that additional vertical shift away from the axis of rotation. So what I'm doing is I'm taking how we are defining our curve, y, subtracting the axis of rotation because we are above it. So if I think about this geometrically, there's a height. I need to consider that extra plus 1 in there. Going on, doing our integration. Our bounds are going to go from 0 to 1 over the x because we are doing vertical washers. So we are going to integrate with respect to x. We integrate from the x value at the start of the area, bounded area, to the x value at the end of the bounded area. So our volume, I'm going to factor out the pi, going from 0 to 1 of, we have root x plus 2 squared minus x squared plus 2 squared dx. keep in mind, sometimes yesterday we may have ended up with a negative area. We missed that axis of rotation, that change of the axis of rotation. So we may have come up with something that did not quite work. I would distribute my exponents in there, multiply that out, might make it a little bit easier to integrate, and since I'm here, I'll just go through, do the whole thing. There we go. Let me know if there's anything else with which I can help. Send me an email.